In this lesson, we will graph y equals cosine x, y equals sine x, and y equals tangent x over the closed interval from negative 2 pi to positive 2 pi using Desmos.com. We will also highlight some of the key characteristics of each of the functions. To begin, we go to Desmos.com and click Graphing Calculator. In cell 1, we enter y equals. For cosine, we can type in COS or click on the Show Keypad button, click Functions. Under Trig, we can find the cosine, sine, and tangent functions. I'm going to go ahead and click COS for cosine, close the keyboard, and type in x. Notice how the graph automatically appears on the right. Since we're asked to graph this function over the closed interval from negative 2 pi to positive 2 pi, let's click the wrench in the upper right hand corner. By default, the calculator is in radian mode. 2 pi is approximately 6.28, and therefore let's change the x-axis so the interval is negative 7 to positive 7. And let's have the step be pi divided by 2 radians. Because the step is in terms of pi, the x-axis is now in terms of pi. And since the maximum cosine function value is 1 and the min is negative 1, let's have the y-axis go from negative 2 to positive 2 by a step of 0.5. Let's close this menu. And now we have a nice graph of the basic cosine function over the closed interval from negative 2 pi to positive 2 pi. Now I do want to mention, if we were graphing this by hand, we would focus on one period of the cosine function, which is 2 pi radians. We would typically focus on the interval from 0 to 2 pi radians, and then break this interval into 4 equal subintervals to recognize the pattern for graphing the cosine function by hand. So let's go ahead and do that. And let's sketch some vertical lines so we can better see what we're doing. Let's type in x equals 0, enter x equals 2 pi, and let's go ahead and change these vertical lines to dashed and black. And now let's break this interval into 4 equal subintervals. So now we'll graph a vertical line at x equals pi over 2, x equals pi, and x equals 3/2 pi. And again, let's make these dashed and black. Let's click, hold, and drag the graph to the left so we can get a better view. And now if we take a look at the endpoints of these subintervals, the cosine function pattern will always be the same. Starting at x equals 0, we have a max. At x equals pi over 2, we have a point at the midline. At x equals pi, we have a minimum. At x equals 3 pi over 2, we have a point at the midline. At x equals 2 pi, we're back at a maximum. So if we take a look at the graph of the basic cosine function over one period from 0 to 2 pi radians and break it into 4 equal subintervals, the pattern is max, midline, min, midline, max. And once we have this pattern, we can continue it to the right and left to extend the graph. Or we can think of copying and pasting this piece of the graph to the right and to the left. And now let's graph the basic sine function. So let's go ahead and turn off cosine, turn off these vertical lines, and go down to cell 7 and enter y equals sine x. Let's click, hold, and drag the graph. So we have a nice graph over the closed interval from negative 2 pi to positive 2 pi. Notice how the maximum sine function value is positive 1, the minimum sine function value is negative 1, the same as the cosine function, and the period of the basic sine function is also 2 pi radians. So while they do have the same max and min function values in the same period, the pattern for the sine function is different than the pattern for the cosine function. So again, if we wanted to graph the sine function by hand, we typically focus on the interval from 0 to 2 pi radians. So let's turn those vertical lines back on. And now starting at x equals 0, the pattern for the basic sine function is midline, maximum, midline, minimum, and back to the midline. Once we recognize the pattern for the basic sine function over this interval, we can simply copy and paste it to the right and left, or continue the pattern to the right and to the left. Let's go ahead and turn off the sine function and the vertical lines, and now we will graph the tangent function. And now let's go down to cell 8 and type in y equals tan x. Right away, notice how the graph of the tangent function looks quite different than the graph of the sine and cosine functions. First, notice how there are no min and max function values because the graph goes up forever and down forever. Also, the period is not 2 pi. The period for the tangent function is only pi radians. Remember, tangent x is equal to sine x divided by cosine x, and since division by 0 is undefined, the tangent function is undefined when cosine is equal to 0. So for a moment, if we turn the cosine function back on, notice how where cosine is equal to 0, there's a break in the graph of the tangent function, and the tangent function has vertical asymptotes at these x values. And now to graph this by hand, we would focus on one period of the tangent function, typically from negative pi over 2 to positive pi over 2, break this interval into 4 equal subintervals, and then recognize 3 key points to graph the function. So let's change our vertical lines to x equals negative pi divided by 2, positive pi divided by 2. Notice how this would be one period of the tangent function. And then we'll break this up into 4 equal subintervals. So let's also graph x equals negative pi divided by 4, x equals 0, and x equals positive pi divided by 4. Turn these on. And again, when graphing the tangent function over this interval, there are 3 key points. The point at x equals negative pi over 4, this point here, the point at x equals 0, this point here, and the point at x equals pi over 4, this point here. So notice how over these 3 points, the tangent function values are negative 1 at negative pi over 4, 0 at 0, and 1 at pi over 4. So over this interval, if we plot these 3 points, the graph simply passes through these 3 points and then approaches the vertical asymptotes at x equals negative pi over 2 and x equals positive pi over 2. Once again, once we have this piece completed and we recognize the pattern, we can continue the pattern to the right and left, or think of copying and pasting this graph to the right and to the left. I hope you found this helpful.